As we've shown many times on this channel before, the Raspberry Pi is an incredibly powerful device for something so tiny. And when most people think of apps and services they can run on their Raspberry Pi, they immediately think of containers. But what if I told you we can easily run virtual machines on the Raspberry Pi in their own isolated environment without needing containers and all the benefits of virtualization? So today I'll be showing you how to run multiple VMs on your Raspberry Pi side by side. That being said, let's go engineer some stuff. There are 5 packages we'll need to install on our Raspberry Pi in our quest for VM virtualization. First one is QEMU KVM. This is our hypervisor. The second one is Libvirt daemon system. This is the system level for Libvirt service calls. The third one is Libvirt clients, and this is the CLI tools like virt that we'll be interacting with a lot throughout this video. Virt-install, which provides the virt-install command and a bunch of other helpful commands. Bridge utils. This will be important if we set up network bridges, which we might cover in this video, but in general, very helpful when dealing with VMs. Since this is an ARM-based system, not x86, we can't check for the standard VMX, SVM virtualization flags we would see on Intel and AMD. And instead, we will use virt-host validate, part of the Libvirt daemon system that we just installed. And here we can see the Pi passes all the important checks, dev KVM is accessible, and virtual networking is supported. Now you're probably wondering, Sam, what about the warnings and failures? Don't panic. A few cgroup warnings show up because Raspberry Pi's OS isn't tuned for containers, but that doesn't affect our VM. So hardware virtualization is ready to go, and we are ready to get started getting these VMs set up. Now, if you go to systemctl status libvirt and find it says inactive, also don't worry. Of course, in my example, it does say active, but I'll explain why. It's socket activated, so it only starts when tools like virt or virt-install need it. In other words, it's ready when you are, so don't worry if you see a status. It will become active when needed and we'll be good to go. For the first step in getting our VM image ready that we'll need, we'll cd into var lib libvirt images, where our ISO need to be kept. For our ISO, I will have downloaded Rocky 10.1 minimal. That'll be perfect for a lightweight VM. Permission-wise, we do have to use sudo ls to actually see our ISO, otherwise we'll get a permission error. And one thing I like to do is grab the checksum file to make sure our ISO download wasn't corrupted. Once again, listing the name of our ISO file. Then if we cat the output of the checksum and grep for our ISO's file name, we can see the expected checksum. With SHA-256 sum and our ISO's file path, and then grepping the expected checksum, after a few moments, we should see that the expected checksum matches the SHA-256 sum of our ISO file, and we're good to go to start resourcing out our VM. There's 3 resources we want to check for our VM: disk space, memory, CPU. For disk space, by doing a df/-h, meaning show the disk space stats for the root file system in a human readable form. I'm using a 256 gigabyte SD card, which between formatting and other files, I have 229 gigabytes free, and we'll use 30 gigabytes for the VM. This way, if we want to add a second VM, we have plenty of room. For memory, doing free-h, meaning show the free memory, also in human readable form. I have a 16 gigabyte model Raspberry Pi, and we'll use 4 gigs of memory for the VM. You may need to scale this back depending on your Pi's memory, but I would really not recommend anything less than 2 gigabytes for performance sake. Lastly, for CPU, nproc will give us the most basic info we need, and it'll return 4 in this case because of the 4 cores of the Raspberry Pi. And it's important to remember, since this is an ARM processor and not an Intel or AMD x86 processor, we don't have hyperthreading or simultaneous threading. So for us, those 4 cores literally do mean 4 vCPUs, but they are shared by the host as well, and we don't want to bog down that host, so we're only going to use 1, and so we could run multiple VMs if we wanted to. Now let's actually get to set up our VM with virt-install. So let's break down this command. Name is whatever we want to call the VM. In our case, I'll call it Rocky. Memory, 4096 and vCPUs 1. We'll be allocating 4 gigs of RAM and 1 virtual CPU. Perfect for a lightweight setup like this. For disk path, this is the correct path that we want to use, and we'll call it Rocky for the QCOW2 format disk that the VM will expect, using 30 gigs for now, as we talked about earlier. The location, this is pointing to the Rocky 10.1 minimal ISO that we downloaded earlier. For OS variant, Second, we're using Rocky Unknown because Rocky 10.1 is new, so this version of virt doesn't necessarily know what version of Rocky is there. For network type, this is very important. We're using direct. Source is our Ethernet, ETH0 to be specific, and in bridge modes. This will connect the VM to the Pi's Ethernet. It will get an IP on the home network that we're using through DHCP. And a word of warning, I highly recommend using Ethernet. If you use the Pi's wireless interface, there are all kinds of issues you'll run into with bridging issues, NMCLI commands, routing, and that's really not something you want to get when trying to set up an example like this, so really do stick with the Ethernet interface. Then the last couple of arguments we've passed, graphics, none, because we're not going to be using VNC or a GUI for this. Simply text mode. Extra args is pointing to the console connection that we're going to do, so this way we can connect to our VM, and no auto console just means we'll connect manually with virt console instead of it taking us right into it. Executing the command, we'll see it'll start the install, it'll go through all the various steps, and then we can connect to the console to proceed with the rest of the Rocky VM installation. To complete our VM install, let's jump on the console with sudo virt console rocky, the name of our VM, and we'll start to see some of the startup notifications and startup and boot information. And if we jump now into the installer, I'm going to walk through the installer fairly quickly, but if you have any questions, let me know down below and I'll definitely answer them. The key things are to make sure our installation source is set to CD/DVD and that our installation destination is our VM's disk. And for partitioning, we want to use all free space and LVM partition. Also, we will create a user that will help log into. I called mine Sam, but you can call yours whatever you want, and we will set a password for that. And setting a root password is helpful to easily switch to the root account when needed. For software selection, leave that as is, as we don't need any of the suggested packages since this is a basic VM. We can press C to continue the install, and eventually when the install is complete, we'll be prompted to hit enter, and then the machine will reboot. As it's rebooting, it actually disconnects us from the console, and we'll have to power on our VM again. With the virt-install, we'll see our VM instance is currently powered off. Let's start our VM with virt start rocky. Then with virt-install, again, our VM is now running. Connecting to the console with virt console rocky, we can see some of the startup messages just finishing up, which is perfectly normal. To log in, we will use the user account we created with the password we set up during the installer. Now that we are into our VM, I want to make sure DHCP has assigned the VM an IP address. This way we can SSH into our VM and don't have to do everything from the console. Running IP address show, we can see yes, we got an IP of 10.0.0.14, exactly what we want to see. Let's SSH into our VM. Important to note, I am doing this from my Windows desktop, not from the Pi itself. The way we have the networking mode for the VM, this won't currently allow direct access from the Pi. A quick who am I shows I am logged in as my SAM account, and we can do the same by switching to our root account and showing that we are indeed root. And just for fun, cat etc os release will show us we are indeed running Rocky Linux 10.1 Red Quartz right here in our VM. For a fun demo, we will set up a web server using nginx. Sudo dnf install -y nginx will install the nginx packages for us, and we will need to enable nginx with sudo systemctl enable --now nginx. Sudo systemctl status nginx will show it's now running and active as of about 20 seconds ago. And since it's be pretty boring to just use the standard default page for nginx, let's customize it to say whatever you want. Can do this with echo the text you want to say, then piping that and doing sudo t user share nginx html index.html. Then we restart nginx service so our changes are picked up and a status check shows it is back to running and active just like we want. By default, Rocky's firewall only allows SSH, Cockpit, DHCP, and a few other core services. So even though nginx is running, HTTP traffic is blocked until we explicitly allow it. Let's enable the HTTP service and firewall, and don't mind the red warnings, I simply forgot to record it the first time I ran the command. Then we reload the firewall so the rules take effect. Quick firewall cmd list all shows that HTTP is now allowed through. Now in Chrome, I'll go to the VM's IP address, and there it is. Hello from Rocky VM on Raspberry Pi. This is just a simple demo, but running a full virtual machine on a Pi opens up so many possibilities. I already have a few ideas for future videos, so like and subscribe if you want to see more like this. What's better than one VM running at once on our Pi? Well, two VMs, of course. So currently our VM is running, but first we'll need to shut down our first VM that we created using the virt shutdown command. Then if we check the status, it should be shut down. For the clone command, we will run virt clone -- original will point to our original VM named Rocky. -- name is what we want to call our new VM. I'll just call it rock2. -- file is the new VM's dist file that will be created, also rocky2, but in the qcow2 file format. Listing our VM status, they are currently both shut down, so let's power them both up. Sudo virt start rocky and sudo virt start rocky2. And if we check our status again, both VMs are now running. Heading onto the console with sudo virt console rocky2, we can see we are indeed running Rocky Linux 10.1 red quartz on this VM, just as our other one, because it's an exact clone. And if we do an IP address, we can find out what SSH IP we'll be needing, so we can make that connection, which is going to be 10.0.0.41 in my case. With our IP addresses, I have SSH'd into them and set Rocky VM1 as our hostname for our first VM, and set Rocky VM2 as our hostname for our second VM. And what's cool is since these are clones of each other, Nginx should be running on both, which when we check, we can see Nginx has indeed been running for about 11 minutes. As a final cool demo, heading back into Chrome and our browsers, on the left we have our first VM, 10.0.0.14. On the right we have our second VM, 10.0.0.41. And as we can see, hello from Rocky VM and hello from Rocky VM2 running on the Raspberry Pi. So here we have it, Nginx running on two VMs side by side, all hosted on our Raspberry Pi. You now have not one, but two fully working virtualized Rocky VM instances running on your Raspberry Pi. I have a bunch more virtualization ideas that I'd love to cover in future videos. Maybe we'll see how many different VMs we can run of different kinds at once. Who knows? Or maybe a virtualized K3s cluster. If you'd like to see that, let me know down below. So make sure to like and subscribe for more adventures on Sam the Engineering Man. Thank you as always. See you all in the next one.